Look at this wall. There is only one door that opens and allows access to the other side. All the rest are locked. Similarly, in any molecule there are only certain places where a reaction can take place. These are the reactive sites of the molecule. Functional groups are the sites of chemical reactivity in an organic compound. Functional groups are defined as specific groupings of atoms or bonds which are part of a larger hydrocarbon chain. It is necessary that you should be able to recognize these groups by structure and by name. Some common functional groups are alcohols, aldehydes, ketones, and carboxylic acids. Double and triple bonds are also functional groups. Another functional group is of the halogens, such as fluorine, chlorine, bromine, and iodine. Today, we will discuss the IUPAC nomenclature of some common functional groups. Let's start with alcohols. In order to name this compound, we must first identify the longest continuous carbon chain. In this example, as there are 3 carbon atoms, the parent hydrocarbon is propane. Now drop the last letter, E, from propane. This becomes the prefix of the molecule's name. Next, identify the functional group. In this case, it is an alcohol. Take the last 2 letters, OL, from alcohol and add as suffix to propan. The IUPAC name of this compound is propanol. Look at this compound. In order to name this compound, we must first identify the longest continuous carbon chain. As there are 4 carbon atoms, the parent hydrocarbon is butane. Now drop the letter E from butane. Next, identify the functional group. In this case, it is an aldehyde. Take the first 2 letters Al from aldehyde and add as a suffix to butan. The IUPAC name of this compound is butanol. Did you know that the sweet smell of ripe apples is due to an aldehyde named ethanol? Ketones are named in a similar way, by replacing the final E of the corresponding alkane name with the suffix ONE. This 3-carbon compound is named propanone. Some hydrocarbons have a double bond between 2 carbon atoms. These are called alkenes. In order to name alkenes, the prefix is determined by the number of carbon atoms in the hydrocarbon chain. The suffix is ene. Can you write the structure of propene? Alkynes are also unsaturated hydrocarbons. They differ from alkenes in that they have a triple bond between 2 carbon atoms as a functional group. In naming the compound, the prefix is determined by the number of carbon atoms in the hydrocarbon chain. The suffix is YNE. Did you know that one of the more interesting classes of new anti-cancer drugs is a group of naturally occurring alkynes? How do we name this compound with a carboxylic acid functional group? Once again, the prefix is determined by the number of carbon atoms in the hydrocarbon chain. A 3-carbon chain tells us that the parent molecule is a propane. Now drop the E. Since the functional group is a carboxylic acid, we add OIC acid as a suffix to propan. The IUPAC name of this compound is propanoic acid. A halogen atom attached to a hydrocarbon acts like a functional group. Fluorine, chlorine, bromine and iodine are common functional groups. Let us take the example of bromine as a functional group. First, determine the parent hydrocarbon by counting the number of carbon atoms in the chain. As there are 2 carbon atoms in this compound, the parent hydrocarbon is ethane. Use the prefix bromo when the functional group is bromine. This compound is named bromoethane. When the halogen is fluorine, the prefix is fluoro. When the halogen is chlorine, the prefix is chloro. Try and name this compound. Did you know that the simplest carboxylic acid is methanoic acid, which occurs naturally in the venom of bee and ant stings?